Hi everyone, it's Peps here, welcome back to my channel. In this video we're going to create this little HDA that will allow us to create and mix as many noises as we want on our input geometry. The way it works, we can just add as many noises as we want with this button here. And as you can see, a noise will be created. We have the classic noise control plus some other value that we're going to set, like this rotation value. And here we have the blending mode and the possibility to remap the single noise output. So basically we can layer the noise like this, and this is very useful if you need to create, let's say, some density value or any mask you may think of actually, because typically you always want to combine a few noise together. You won't get a very interesting result with just one noise driving the whole thing. Of course, all these parameters can be animated. And finally, we will add a possibility to clamp the final output and also to rename the attribute, which by default will be written as a mask attribute on the points. So starting from a Houdini empty scene, let's drop down a geonode and inside drop down a grid. This will act as our input geometry for testing, and since this attribute will be written on the point, we want to crank up the resolution of our surface. So let's say 400 by 400. And let's drop down a point bop. This will be our noises, so let's call it noise. And in here we want to dive inside. In the point bop, let's take turbulent noise node. This basically will be the core of our noise. We want to sample the position and we want to output the attribute, let's say to the color for now, so we can have an immediate visual feedback. And for the noise, we want to promote the type, the frequency, the offset, basically everything but the attenuation, because we don't need that one. So also the turbulence. And if we go outside, we have our classic setup with the noise on a surface. So let's start to create the HDA right away. We want to select the point bop node because the grid will be the input, so it will be outside the HDA, and press Shift and C. This will create a subnet, so we want to right click on it and create digital asset. Let's name it multi-noise. And as you can see here, you have the tab for the destination of this digital asset, and also the option to add the author name and the version. You will see that the internal name will be this one, and the name for the file will be this one, alongside the location on where the file will be saved. So we want to create this one. And as you can see, the type properties will open. We want to apply and accept. And remember, from now on, since this is an HDA, we can't edit the interface from here. We need to right click and choose type properties. So let's leave this one open because we will build all the parameters here. And also for convenience, since we will need to link a bunch of parameters, I want to click here and choose split pane left and right, so I can pin the HDA interface here, and when we will dive inside, we will have all the other stuff on the right side, so we can link the parameter more easily. So now we want to drag all the control we want on the HDA from the point bop. So from here, let's say noise type, we want to drag it on the HDA interface. So let's take also the frequency, the offset, and the other ones, amplitude, roughness, and turbulence. Now, if we apply and accept, sure enough, we can control the noise from the HDA interface as usual. The problem is, this one is just a standard noise, a single one. There's nothing special about it. What we want is something similarly to the add node, where we can control as many entries as we want. And this is what is called a multi-parameter block list. So let's delete this add node. We want to go back to the properties of the HDA. We want to drag a folder onto the root. Let's call this one add noise. Let's call it also noise fold for the name. And we want the type to be multi-parameter block list. If you apply, you can see that now a button similarly to the add node is appeared, and we can add as many entries as we want. Of course, right now only the number is increasing because we didn't set anything yet. What we want to do is to take all the parameters we promoted in the HDA and drag it inside the new folder we created. And as soon as you apply it, you can see that something is changed on the names of these parameters. Basically, on the name, this number sign has been added, and this is a feature of the multi-parameter block list. On the frequency and on the offset, also this underscore has been added, I believe because those are vector parameters. Let's delete the underscore. And I also want to set the frequency as a single value float and the offset as a float vector tree. So apply, and now if we add an entry to the add noise, you can see that we have a copy of those parameters. And if you hover on a parameter, you can see that the first one is frec1, the second is frec2. Basically, this number sign will be replaced by the instance number. Now let's apply and accept. And if we go inside, I believe that everything should be broken. Yes, it is. Let's replace every number with 1 for now. So on the offset, and this of course needs also the letter at the end because we converted to a 3-float vector. So y and x, and this should be everything at 1. So the problem is now, as you can see, we can link to a single parameter, right? And basically this is taking the first one. The second is not taken into account because the names, every name of this instance contains the number 2. So what we need to do is basically to create a for each loop inside this HDA. So we want to take a for each, let's say, start with the point 1. We change what we need to change after. This will be the input of the subnet, and we want to put the point VOP inside. For the loop here, we want to set it to fetch feedback, and we want to create also a meta import node. So click here to create the linked node. And on the for each end, we want to set it by count to feedback each iteration. We don't want to merge each grid on the other one. And this value basically need to be the add noise value. So it will be a loop for each instance we will add in here. So on the iteration value, we just want to write ch, and the path is not to noise fold, the parameter we created with the name of the folder. And as you can see now, it matches the iteration number based on how many noise we create on the scene. Let me delete some of the entries here, so we have just these two. And now we need to find a way to tell this point VOP to use not an hard-coded number like this, but to use the corresponding iteration value. So first we want to create a spare input on this point VOP. So click on the gear icon and add the spare input. And we want to drag the metadata node here so we can count this iteration number. So drag it here. And now we can refer to this node as -1 regarding the index, right? If you remember, the index order is 0, 1, 2, 3 to reference the input number. And if we use -1, we reference to the first spare input. As you can see, if you hover it, it says refer to this expression as -1. If you will add another spare input, you will go lower, so -2, -3, and so on. So we want to right click, let's say, on the frequency, choose expression and edit expression, so we have a bigger window. And what we want to do is basically to concatenate two strings. The first string will be the name of the parameter, so in this case /frequency, and the iteration value. So in the first case will be 0, but we will add 1 because this kind of parameter will start from 1 and not 0. So basically we need to say frequency plus the iteration number, which is detail -1 to refer the space parameter. We want to take the iteration value, which is already written on this node. If you click on it, you can see that by default, it will output the iteration number, the total number of iteration, and other stuff. And the index is 0. Of course, this basically we can't add a string to an integer value like this. So first we need to convert this detail value to a string with the f2a expression, and we need to put this between brackets. Also, we want to add 1 to this value, so the first iteration will be 1 and not 0. Of course, we can't add to string like this. We need to use another function called strcat, I believe. Let's try it. strcat. Yes, as you can see, it does exist. And it takes two string as argument, and basically it merge the two string together. So we want to add frequency, which is the first argument, and this other string, which in this case will be 1. So delete the plus sign and put another bracket. Apply, and let's see if we don't have any error. Yeah, it's not working. Frequency, F2A. Oh, yeah, we need to evaluate this as a channel, of course. So CH and another pair of brackets. And as you can see, now it's taking the value. For the other one, we want to copy and paste the value. So now the link is working, but if we go at the end of the loop where we have two instances, as you can see, the first one is not doing anything anymore. We are controlling with the second one because this one, of course, will be put on top. We don't have any blend small available yet, but this means that it's working because now this is controlling the noise with the frec2 value. Now let's copy this expression and we want to paste it on the amplitude, roughness, and turbulence. And we only need to change the name to amp, this one to roughness, rough, and this other one to turbulence, so turb. And if it doesn't update, even where it should, just click on the loop and choose reset cached path, and this will refresh the behavior. So these three parameters are working correctly. For the noise tab, we need to right click and open the expression, otherwise we can't write on here, and paste it, but we want to change the type to be CHS, so it will be a string, and this, I believe it was called type. So apply, accept, and yeah, it is working. Now for the offset, let's right click and open the expression. Here we want to paste the expression, but we actually need to do another concatenation because the offset, being a 3-float value, also has the X, Y, and Z letter at the end of the parameter name, and it is after the iteration value. So we want to add another strcat expression, and basically this will be the first argument of the second concatenation, and the second argument will be X. We need another bracket now, and let's change the name to offset. Apply and accept, and as you can see, is working. Let's reset. It's working on the wrong axis. I don't know why. Let's check it. Okay, this is weird because if we copy and paste it here, change it with Y and also here with Z. Let's see. Oh, it's not working anymore. Let's see why. Offset 1, X, Y, and Z. Oh, there's only one T. Let's type properties here and let's fix this name. I believe there's 2T in offset. So let's apply, accept. Let's reset it. Okay, it is working. And if we go at the end of the loop, the second noise should control everything. And if we add another one, we have the last one controlling the noise. Now, before we start to take care of the blending modes, we want to add the possibility to rotate the noise also. So we want to go back to the HDA interface. Let's choose type properties. And in here, we want to take another float vector 3, drop it after the offset. We will call this rotation, and the name will be rot. And as before, as soon as we apply, the number sign will be added to it. So now inside the loop, we want to calculate the rotation before the point VOP. So let's take a point wrangle and plug it before the VOP, right after the start of the loop. Let's call this one rotate. And to reference the multi-parameter list, it's actually simpler compared to using HScript, because in Vex we can plug the metadata node in the index number 1, and here we can write an integer variable. Let's call this iter, and it will be the detail from the input number 1. We want to take the iteration value with index 0 plus 1, just as we did inside these expression values. So now to sample the rotation channel, we actually want to create a vector variable. We will call this one rot. And to sample the channel, we don't need to use this strcut. I mean, we can't use it because this is HScript. And in Vex, we want to use this sprintf function. Basically, this one will take, similarly to the strcut, two arguments. The first one will be dot slash rot, we call rot, and the second argument will be the iteration value. Now, with this sprintf function, we don't need to convert the iteration value to a string, because this function doesn't actually concatenate to string. If you open the documentation, as you can read, it formats a string. Basically, it appends the value of the second argument at the end of the string. And if you click on the printf, which is the reference for this function, you can see that we have some symbols here. Basically, at the end of the name of the parameter, we need to include the percentage symbol and one of these letters, depending how you want to append this value to the string. In this case, the G for the general form will be fine. So let's write percentage sign and G. Now we get an error because we need to evaluate this as a channel. So CHB and close the bracket at the end. And if we want to check it, we can quickly write this rotation to an attribute. So like this, and in the geometry spreadsheet, we can check if the parameters are linked. And let's go on the rotate. doesn't appear it's working. Let me reset the loop. Yeah, it is working. Whenever you see that something it isn't updating, before debugging your code, if you're in a for each loop, always check if you solve it by resetting the cached best of the loop. Now, to actually apply the rotation, we want to use matrices. As you may already know, we can actually manipulate geometry with matrix operation. And without going into deep into matrix, we just need to know for this case that we can rotate points if we multiply their position for a rotation matrix. So we want to create this matrix. So let's make some space and create a matrix tree. We will call this rotmat. And to create the matrix, we want to use this function. Let's open the documentation and type make transform. As you can see, it builds a 3x3 or a 4x4 matrix. We can use a 3x3 for the rotation. And we have many variants. As you can read, we want to use this one, which only takes 2 arguments. Basically, it takes this, which is the transformation order, and the angles of our rotation. Basically, it takes the channel we are referencing from the HDA. And the first argument, if you scroll over the function, you can see that we have this one we can use. Sorry, not this one. I believe is, yes, y, x, y, z. So this one. And we can use the first one. So x form x, y, z. Let's copy it. And here we want to type make transform. So the first argument will be this x form x, y, z, and the second argument will be the vector we created, so rot. And now let's hide the documentation. Let's quickly test it with, let's say, at p multiply or equal by rotmat. So now we can rotate the whole thing with this channel. Of course, we don't want to actually rotate our geometry, so let's delete everything here. And we want to bind this rotation to a new attribute. So let's call it vector at rest. And it will be our position multiplied by the rotmat. So basically, we still have this information. It's just not on the position, but on this new created attribute. The problem is that now the noise is sampling the position, so it's not doing anything. So we need to go inside, and instead of using the position for sourcing the noise, we want to use a bind node and take the rest attribute we created. And it's a 3-float vector, and we want to change the input for the noise. So now let's reset it, and we can actually rotate the noise without touching the position. Of course, if you rotate on the X or on the Z, you will see this weird behavior because it's rotating on the origin and we have a grid as our source. But let's take a sphere so we can also check on different geometries. Let's reset the radius to 1, put the uniform scale to 5, and increase the subdivision. Make it as a polygon and give like 60 subdivision. So now we can see that the rotation is not working anymore. Why? Let's go outside. Oh, because the second one is on top, right? But as you can see, everything is working so far. So now we need to take care of the blending modes. But before doing that, we actually want to take care of something, because I don't want to work directly on the color. I want to work on a simple float attribute. But the fact of the color is displayed by default is very convenient for us. So how can we fix this thing? First, we want to go inside the point VOP, and we want to break the connection with the color and bind export. the result of the noise to a new parameter. We will call this one noise. So everything is still inside, we just don't see it. We could create a visualizer for it every time, but it's not very convenient. What we want to do is to create a new point wrangle after the loop, and we want to use it. Let's call it a CD preview. Here we want to set a point attribute, so let's use the function set point attribute. We want to set the color attribute, so CD on the current point number, and close the quotation for the string. And we want to use the noise attribute we created to drive it, so f at noise, but we want to explicit cast as a vector, so vector and bracket this one, and the mode will be set. So here we have the noise back as a color attribute that we can immediately see it. The problem is if we go out, we will see the output, right? But we can fix this thing by duplicating the output. The output for the preview will be index -1, so it won't be visible from outside the HDA. And now we can use a little Python method to tell Houdini that this output will be used only for display purpose. Basically, we want to use this method, set output for view flag, on this output, so -1. So we want to take a Python node, and it will be the first node of our HDA. And let's see, the current node is already referenced here, and we don't want this geo node, we want the whole HDA. So let's create a parent variable, and it will be node.parent. So we have the reference to this entire HDA, and now we want to say parent set output for view flag, and the output will be -1. So if we did everything correctly, if we go outside, we still see the output -1, but it's not written on the color attribute. It's just for displaying purpose. So let's go back inside the HDA, and for the blending mode, let's I took as reference this height field layer node to have some basic blend modes. I use basically all this one except the replace, but you can create whatever blending mode you want. You just need to know the correct calculation for it. So we will add this one to the HDA. Let's delete this node, and on the HDA interface we want to add an ordered menu at the end of the noise. And on the menu tab, let's type our modes. So the first one will be add, then we will have subtract, difference, 4 will be multiply, no, 3 will be multiply, 4 will be maximum, 5 minimum, and 6 will be blend. Apply, and also let's give it a name. We will call this mode, and it will be mode number sign. So apply, and now we have a menu for each noise. Now inside the loop, make some room after the noise. We want to drop down another point wrangle. Let's close this menu by accepting. Let's call this one layering, and like before, we need the iteration number, so plug the metadata node in the first input, and let's copy it from here and paste it here. We also need the incoming noise, so let's create a float variable. Let's call it noise, and take the noise attribute we created in the point bob. Now to reference the medium, just like before, we want to create an integer channel because the menu will reference to the integer index. So int mode, it will be equal to chi for the integer channel reference. And like before, as printf function, the path is to mode, and we need the percentage sign and the G symbols, and the argument will be iter. Another bracket and close it. So now if we test it by creating an integer attribute, let's call it mode, and on the geometry spreadsheet, let's highlight the node, which should see something changing here on the second one, right? Yeah, the reference is working, so delete this attribute, we don't need like that. And basically now we want to establish a series of if condition based on this menu here. So the first one will be if the mode will be equal to 0, so it's the first mode, the add. We can open curly bracket and we can create a new attribute. We will call this mask, and it will be plus or equal the noise we created in the point bop. So let's close the bracket and let's check if they are adding together. And we need to change here on the color wrangle the sourcing for the color attribute because it's still taking the noise. We need to take the mask at this point. So now, as you can see, the two noises are adding together. So go back in the layer wrangle and let's establish the other condition. The second one is the subtraction. So let's continue from here and let's write else if mode is equal to 1. We can copy this line and paste it here, but it will be minus equal the noise. And now we can copy these two lines and let's paste it for the other ones. So else if the mode will be 2, which is difference. And the difference operation is basically a subtraction, but taking only the absolute value. So fmask will be equal to the absolute value of at mask minus the noise. Let's paste it again. If mode is equal to 3, which is multiply, so fmask multiply or equal the noise, and paste it again. Mode number 4 is we have maximum and then minimum, so we can use the function, delete this minus sign, the max function between the f at mask and noise. Let's copy the last line, we can paste it for the minimum, just change the mode to 5 and the function to minimum. So everything should work, but we need the final curly bracket. And now let's see, we have the first one with a big frequency, the second one with a little frequency, and if we change the mode, yeah, it is definitely working. Let's go back and plug the grid, which is better for visualization. So the first noise is the big one, and it seems that every blending mode is working, except the blend. We still need to create this one. Now for the blending mode, we need to use the layer function, and as you can see, the layer function requires an amount. So we need to create another parameter here, which will be the bias for the blend. So let's go back. I, for some reason, closed the type properties. So here, after the mode, we want to create a float channel. This will be the bias for the blend. So bias, apply, and we do have this channel, but we want this to be visible only when the mode will be set to blend. So here where it says hide when, we want to open and close curly bracket, and inside we want to hide when mode is different than, I believe it was 6, and also we need the number sign. Apply, and now the bias parameter shows only when the mode is set to blend. So back inside, let's close this one. Just like before, we need to reference to this bias parameter. So here after the mode, let's create a new variable. It will be float bias, and we can copy this line, paste it here. It will be a CHF, and the name was bias. So now we do have the reference to this parameter, and here as a final condition we want to say else f@mask it will be equal to lerp function, and it will lerp within the f@mask and the noise driven by the bias. Close bracket. Now if we set the first one always to add, otherwise you won't get basically anything. And let's check. I believe the blend is working as intended. Of course now it's overdriving because by default it takes a range from 0 to 10, so that will be a good time to set some default value. We want to go back to the HDA, open the type properties that I keep closing, and here if you go on the channel you will see the default value. The O noise, because by default this will set the noise to original Perlin. Let's put noise, which is the first one, is the lighter one, the Perlin. On the frequency, 1 is fine, 0 for the offset is fine, also for the rotation. Amplitude, roughness, turbulence, everything is fine. The mode is on the add, and the bias we will set this to 0.5. On the parameter tab and on the bias we want to lock the range and set it to from 0 to 1. The amplitude and the rest seems fine, so let's just apply and accept. So now we do have the bias going from 0 to 1. And now if we create another noise, we should also have some good default value, and we do. So all good for the blending mode. Now on the wrangle at the end, let's just remove the noise and the rest attribute to make it more clean. So remove point attrib. From the geometry 0, we want to remove the rest. Let's copy and paste this line and also remove the noise. We just need the mask from this point on. So everything should work correctly. And it seems it does. Yeah, so finally we want to add the possibility to remap the single noises. So back in the type properties, we want to create first a toggle, because maybe we don't want this remap enable. So call it remap, give it a name, and by default will be 0, so off, which is fine. And now we need 4 float parameter. So we need all the new minimum and all the new maximum. So this one will be all the min, which we don't want to lock the range actually. So let's just say that it will be hidden when the remap will be off. So curly bracket, remap number sign is 0. So now it should be visible, yeah, when we enable the remap. Let's copy this channel and paste it 3 times. This will be old max, and be careful with the names here. Apply and do the same with the new min and new max. So this will be new min and this will be new max. So we have all 4 channels. Now go back in the wrangle and let's sample the channels. Also, I do apologize, I remember just now to zoom the wrangle interface. So here, after the bias, let's first create the channel for the toggle. So int remap. Let's copy this line, paste it here, and the name was remap. For the float channel, let's create float old min. Let's copy this one, which is already a float, and it was the name is old min, right? Let's copy and paste it 3 times. So this will be old max and will reference to old max, and min and max, and they will reference to new min and new max. Apply and everything should be fine. So after the blending mode, we want to apply another condition. So if the remap it will be equal to 1, then our mask attribute will be equal to the mask attribute in a fit function. So we will fit the current mask from the old minimum and the old maximum to the new minimum and new maximum. Let's close the bracket. Let's apply and accept on this window, and let's see. Let's delete the first noise. Also, let's change the range for this one. Let's set the default max to 1 to all of these parameters. And on the default channel, let's set the maximum to 1 and leave the 2 minimums at 0. So apply. We have 2 more convenient sliders. And I also believe the remap is actually working. Let's say we have an original purlin, which by default it should go from negative 0.5 to 0.5. Yeah, it seems everything is working. We can add another noise, maybe an alligator, and set the blend mode. We also can remap it. And I believe that's it for the single noises. Now we just want to add some global controller, one to rename the mask to another name, and one to clamp the global output values, all the noise combined together. So let's open the type properties, and in here also let's drag another folder inside the add noise. Let's call this folder noise with the number sign, and it will be folder underscore number sign. Apply. So we want to drag this at the top and put all the controls we created inside this folder. So it will be more organized for single noises. Now, for the global parameters, let's first take a label and put it right at the top. This will be our global parameters. Those are just a label to identify better in the HDA interface. So this will be a global label. Apply. and you can see it's just a title. We want to duplicate it. This will be noises label, and we want a separator between those. So basically now we will create all the global controls over here, and they will be nicely apart from the single noise control. So for the renaming, first we want to have the possibility to rename, so we need a toggle. Let's call it rename. And we need the field to put the eventual new name. So we need a string after the rename. This will be new name. Let's call it new name. And this will be then when the rename is off. So curly brackets, rename, it will be equal to 0. So if we apply and enable the rename, the field to set the new name will appear. And for the clamp, we also want a toggle. Let's call it clamp. Set the name to, let's say, clamp on. And since it's a clamp and not a feed, we just need two values, one for the minimum and the maximum. So let's create a couple of float channel. Let's call this clamp min and duplicate it. And the second one will be clamp max. Let's also set the range from 0 to 1. We don't want to lock it. And the default will be 0 for the minimum and 1 for the maximum. Apply everything. And now we do have the controls, but we want this to be hidden. So on the parameter page, hide when clamp on is equal to 0. Let's copy it, press enter, otherwise it will be deleted, and copy it here. Apply, and now we have the controls accordingly on the toggle. So now we have the controls. We want to go back into the HDA, and after the loop, now we are done with the single noises. Let's take another point wrangle. This will control the clamping, so let's rename it to clamp. And here we want to sample the toggle, so let's create an integer variable. Let's call it clamp, and it will be equal to the integer channel from the clamp on channel on the HDA. As always, if you want to test it very quickly, just bind it to an attribute, and we can check it on the geometry spreadsheet that it is working. We don't need any percentage sign, any sprintf function, because we are not dealing with the multi-parameter anymore. We are just on the global geometry. So let's delete this one. And now we can say that if clamp is equal to 1, we want to write a new mask, which will always be called mask, at least so far. And we will clamp the incoming mask with the float channels, the clamp minimum and maximum. So open quotation mark, / clamp min, and same for the clamp max. Let's close the curly brackets. Sorry, there's a little space here. And now we should have this should go into the CD preview also. And now, as you can see, we can clamp the final output. Now let's take another point wrangle. This will take care of the renaming. So call it rename, and in here let's take the channels. So the toggle, let's call it int rename, and it's chi, and the name is rename. Yes. We also want the string from the new name field, so let's create a string variable. Let's call it name, and it coming from CHS, the new name, I believe. Yes, new name. And now we want to say if rename is on, so equal to 1. We want to set, basically we want to set a new point attribute with the new name, and that attribute will take the current mask value. So we will use the set point attribute function, set point attribute, geometry 0. The name will be the name we will write in here, so name coming from the variable. On the current point number, so at ptnum, and the value will be the current f mask. The mode will be set, and if we want to rename it, maybe we also want to remove the current mask, so remove point attribute. We want to remove the mask value, semicolon, and close the brackets. So now we do have we do have nothing because the rename is on, but we didn't specify a new name. Let's type test. You can see that is appearing right here. If we disable the rename, we have the mask attribute. So we can apply and accept the interface the final time, I believe. Right click, save node type to save the HDA. And if you want to get rid of the red lock, which basically tells you that you can modify this HDA, you just set it to match the current definition, and this will lock the HDA. And if we take a null after it, we can see that also the color display is working only on this node, but we still have the mask value. If we take a color node after it, and let's say ramp from attribute, and the attribute will be mask, we still have that information. And I believe that's it for the HDA. We created everything, and we can switch geometry. As you can see, it works no matter the geometry is. And you can also, of course, animate everything inside here. And for the presentation of this tutorial, I just used this technique. I basically had a very dense grid of points scattered, and I used this HDA to create two different noises, which are both animated, and added together to create a p-scale value. Then I used one of the masks to drive the color value, and basically I just copied a line on the points with the p-scale driving the length of the line. Then it's just a matter of adding some thickness to it. And what else? I believe in Karma I just used the second mask, only the second one, to drive an emission channel. You can see that the base color is taking the CD regular value, and this emission value is taking this mask 2 attribute. And that's it. It's really nothing special. So that's it for this tutorial. I hope you, as usual, enjoyed my content, and don't forget to subscribe to the channel and drop a like if you did. So see you in the next one.